Today we're working on a 2000
Chevy Blazer. Customer states that the left rear tail light is not bright, or it's dim compared to the other three. If you look on the right side, these two are pretty bright. This one's bright, and this one looks a little bit dim. It is working. We'll get up there closer, and if you can see that it's working, it is lit. This little Chevy emblem here is a part of this tail light. Okay, we're going to turn the car off. We verified the customer's concern. I'm going to come in here, shut it all the way off. The other thing I'm going to do is I'm going to turn the car back on, just in the run mode, not the it's key on, engine off. Okay, so keys on, engine's off. It is remote start. We got to make sure, or it's got the push button start, so we had to do that. We want to make sure that our headlight switch is on to the on position. If we turn it to auto, it may come on, it may turn off, one of the two. So we're just going to leave it on the on position. We'll come back here and notice that our tail lights are still on. The left one's still dim. I'll open the tailgate here, and a screw here that we're going to take out. There's 7 millimeters. I'm going to take those out, and there's a captive screw back here and back here. I don't think there's actually a nut there, but we kind of have to pressure it, pull a little bit, tug, and it kind of clips out and comes right out. When I see a dim tail light, dim headlight, dim light of any sort, I know that it's working. However, it's not as bright as the rest, and I've compared that already. But I immediately know that the circuit's working. However, the circuit is not working correctly. And when a circuit's working, that's going to eliminate 3 of my 4 circuit volts. A short to ground. A short to ground is going to blow a fuse, and then the circuit's probably not going to work. The short to voltage is basically something's operating when it's not supposed to. So my taillights are supposed to be on, right? If it was a short to voltage, it would be, maybe this light would be on also, and this is the brake light down here, which means I'm not pushing the brake pedal, which means that shouldn't be on. If that was a short to voltage, it's not on, so it's not a short to voltage. Okay, and an open, if there was an open in the circuit, this wouldn't be working at all. So that leaves me one conclusion, that this is a high resistance concern. So we're gonna do some voltage drop testing and figure out where my high resistance in the circuit is. Okay, things you're gonna need to do this. So you're gonna need a multimeter, okay? You're gonna need some back probes, for testing, and you're also gonna need a schematic. And I've got a schematic here. I'm gonna pull this up and in a video so you can see it when I'm talking a little bit about the schematic, okay? But really, we're gonna be dealing with the tail lamp left outer. This is the tail lamp left outer. We're gonna be dealing with this circuit over here. I'll start to talk about this a little bit later, or I'll show you some more when I complete the video, okay? But I know I'm gonna be dealing with red and violet gray and a black and black wires, okay? There's a connector at my tail lamp, which is going to be this connector here. I got red and black here, and there's another connector right here, which is going to be X410, and then this wire comes back and down through the bumper, down into the bumper. All right, so what I'm going to do is, before I start disconnecting stuff, I'm going to check my voltages at the bulb or the light itself. I know in this circuit here, it is a series circuit. So I should have 12 volts dropping across my tail lamp, or I should say all of the voltage dropping across my tail lamp. So I'm going to set my back probes up. There's a couple things we can do here. The back probes aren't long enough to reach down through this connector, so I can slide in back in through here, and I can't get all the way down in there. So there's a cap here that I can remove, take your pocket pry bar, aka your pocket screwdriver, and raise up and kind of pull it up out of the way. Okay, now that allows me to get a little bit back here to this connector, back of the connector. So we're going to come back in here and back probe the red wire. Now you may, when you're pushing that in, you may kind of start to feel a little bit of resistance, or maybe like you're hitting something metal, but we're going to keep sliding in here onto the back of the terminal. I'm going to try and adjust this camera to see if... Okay. Alright, so you see this black wire here? Light on the subject. You want to go between the rubber and the wire with that test probe. And then I'm going to take my meter to here, just because this is the power side or the battery side. Red to here, black to here. And I'm going to measure voltage. I'm going to set my meter, I'm going to set it up real quick so we can see it a little bit. Alright, I'm going to set my meter to voltage. Alright, now I'm measuring voltage drop across my bulb, and I'm getting 5.6 volts. Okay, now where I can go from here is I can do a voltage drop on my ground side and my power side.
We're doing a voltage drop across the bulb, and I'm getting
5.64 volts. Okay. Now, what I'm going to do is I'm going to take one of my leads and measure my ground. Okay. What I can do is I'm going to take my red lead out because it was on the power side. Take my red lead out. I'm going to leave my black lead in on the ground side, and I'm going to find some not painted metal. The closest not painted metal I can find is right here at the liftgate latch. So I'm going to stick it on here. And my meter says 0.002 volts. Okay, so I have no power drop or voltage drop on the ground side, and then I only had 5.5 or 5.6 volts drop on the bulb, which means I have a voltage drop somewhere else. Now, what I can do is I can verify that. In this simple series circuit, there's a power side, the load, and a ground side. So if I'm not dropping all 12 volts on the load or the bulb or the light, whatever we want to call it in this circuit, if I'm not dropping total voltage here and I'm dropping 0 volts on my ground, that means I've got to be dropping it on the power side. Okay, so I'm going to take the back probe of the ground side on my connector at the bulb or the light and go to somewhere else where I can know where there's power at. Okay, now when I'm doing voltage drops and I want to do a voltage drop on the power side, I'm going to go with the red lead to the power and the black lead to a power. Okay, I want to do it that way because I'm measuring voltage drops between a certain distance. Okay, so I've left my back probe in here on this connector, and I'm going to come over here, and there's another connector here because these red and black wires are together. There's another connector over here. So what I'm going to try and do is back probe this red wire and see what I get. Take this out and throw that in there. My back probe set up in here on this other connector. Got my back probe over here on this connector. I'm measuring the voltage drop on the red wire from this connector to this connector, just this red wire, so this 10 to 12 inches. Okay, so in a typical circuit, in a good working circuit, I should get 0 here because I should have 12 volts dropped across my connector here. Okay, so I've got these back probed in already, and I'm gonna stick my lead. I got my lead in one side, and I'm gonna stick the lead in the other side, and I'm gonna see what I get. I should have, there, I have 5.16 volts. Okay, 5.16 volts. There's my voltage drop. That's on the power side of my circuit here. Now, if it was on the ground side, I could do from here to here, but we measured from ground all the way over to the body ground over here, which means, and I got 0, which means there was no voltage drop. Okay, I can go from here to here, and I would, if I did it this way, I'd get voltage. That's my voltage drop through the bulb is 5.5. Okay, there's my voltage drop across the power wire, or the power battery side or power side of my bulb. So our problem is we have a high resistance on the power side of the bulb in my circuit.